Done.
Good morning, everyone. Welcome to another in the series of EMC webinars sponsored by the American Council of Independent Laboratories in cooperation with Washington Laboratories in Gaithersburg, Maryland. We've had a webinar scheduled already in February, and the series are based on information gained from international meetings or even some national EMC standards meetings as they conclude. And what I try to do, since I'm at all these meetings or chair them, I try to schedule webinars that are within 4 to 6 weeks afterwards. And what you will see, in fact, the page I'm showing you right now is the announcement. I struck all the others that are coming up in the future. Bob Uttenweiler has that information if you need it. So let's start the webinar. It should be done in 1 hour. You can see sort of the advertisement there. And here is the agenda that I'll be using. So today the focus is going to be on a major EMC standards activity for smart grid. You can see in item number 1 there, or in fact in the whole title there, it's a long-winded way of saying electromagnetic compatibility, but it's very interesting. When we wanted to have electromagnetic interference, they said, no, you can't do that. It sounds, ominous. So we struck a compromise by calling it Electromagnetic Interoperability Issues Working Group. And SGIP stands for Smart Grid Interoperability Panel. It's a standalone organization that is working on the way in which smart grid is introduced and continuing to be improved in this country, with also cooperation with international people that are doing the same thing in other parts of the world. The obvious one being the European community, but there's a lot of smart grid activity in Japan, for example. So my agenda will cover the charter of this group. I'm going to give a presentation, a PowerPoint presentation number 2 there, of what I'll be giving at the Asian Pacific EMC conference in Shenzhen, China in May. I'm going to give it again at the IEEE EMC symposium in Ottawa in July. Then I'm going to talk a little bit about the organization itself and the members. And the reason for that will be you may know some of these people or you may not, but I would like to just share the different aspects they come from, manufacturing, utilities, and so forth. Then we have set some priorities for the EMII Working Group Charter, and I'll show that timetable. And finally, I'll talk about the draft report that has already been started and some of the questions that are needing to be answered, not only by the working group, but anyone, in fact, you folks may be interested as well there on the webinar. And I'll be under item 7, tasks to be completed. We meet the second Monday of each month from 3 o'clock to 4:30 Eastern Time. Now it's Eastern Daylight Time, as we are in March of 2016. So with that, the outcome I would see, the takeaway I would see, is familiarity with a major organization within the United States that are working on EMI standards, and how it applies to smart grid, and with that, how it might be a background for decision making if you want to get into the testing business or the things that follow on with that, including accreditation, for example. So without going any further, let me bring up the charter here. This was issued, as it shows, November of last year. The scope is, I don't propose to read all this, but I think we will have it available as part of the recorded information And if not, of course, you can always send me an email. But the bottom line is the working group is going to investigate enhancing the immunity of anything in the smart grid. And of course, when we say that, we're talking about devices, not the power line itself. And we're talking about natural lightning and so forth, as well as man-made interference due to local transmitters, for example. And the idea is to, if we can enhance the immunity of those devices, some of which, by the way, are not even tested for immunity, we feel that those devices can interoperate amongst themselves. And the whole idea of interoperate is that you can essentially plug and play. You take a device in the path between the utility provider generation to the customer, and let's say it's easier just to use a smart grid, it's a smart meter. You can take that one out, and if it has a problem, and plug in another one, and the communication channel that is, in addition to monitoring what the power usage, it will continue on working flawlessly. And there are several communication mechanisms that are used, and that, by the way, this way is the smart grid aspect of this, that you have some additional ability for the customer and the utility to communicate with each other. And for example, if there is a cheaper time of the day or night that power is available and charges a lesser rate, then that could be communicated to perhaps turn off a household piece of equipment like a washer and make that work, let's say, after midnight. And of course, in a industrial facility, that is now big money because there's a lot of power consumption there. Okay, so that's the scope and the goal I've already talked about. And by the way, we have as partners in here, and when I show the membership, we have members from the the power providers. We have member from a public utility commission, as well as EMC experts and others that develop standards, which is good news because we have a diverse group. Now, moving on to the activities, and we're going to come back to this later in the agenda as well. In our charter, we said we would like to do certain things, and call it that we've made a contribution. Well, that had to be approved, at least the charter aspect of it, by the technical committee of the SGIP. And the good news is, of course, it has been approved. And in that approval, last November, December, they made me chairman of the working group. I guess I worked too hard to get it passed, and I got rewarded by being the chair. So let me just highlight some of they're very short. First one we identified, reviewed the existing state of EMC on the power grid. Yeah, we have to start somewhere. By the way, these are not necessarily in sequence or in order, but it was a stream of consciousness that we put down what we thought were the top 10 things we might look into. The second one is to evaluate the EM phenomenon and the impact on smart grid reliability. And the two key words there is consider the extent of the issue and the severity of possible failures. So just keep in the back of your mind, I'm going to be talking about extent and severity later on in the webinar and the questions we posed in it. So third one, look at the high altitude EM pulse stuff, the high power, including geomagnetic storms. Believe it or not, this is a very hot topic, even in our U.S. Congress, to see what can be done to handle threats. We're not talking about just nuclear pulses. We're talking about intentional EMI, and so forth. Item 4, there is a document called the Interoperability Process Reference Manuals, so-called IPRM, that NEMA is well along the way working with ANSI to make it an ANSI-NEMA standard. And it is useful for the interoperability power authorities to invoke many things, including business models. But I was able to put into the IPRM a clause on EMC, and with that and cybersecurity being a little bit different than the main area of the IPRM, which again is related more to business models. How can you do a transaction over the power line using the smart activity of a device or so forth. Item 5 here, consider the need of a conformity assessment program. We have actually prioritized these 10, and that is downstream. There is a SGIP Smart Grid Testing and Certification Committee, which I am a voting member as I am for the Smart Grid Interoperability Panel itself. So we are holding this back because until we get something, a program accepted, it's the next step, and so that one is a low priority at the moment. Number 6 is what tests should be performed and how would you set it up? Given that you have a smart meter, what is the drive and what is the load, and what kind of communication should be going back and forth bidirectionally? And there is no obvious test setup, although we have an application guide that we're working on. So if it came to a test house and here's this meter, test for it, test immunity of it. Well, obviously the question you would ask is, well, what does it connect to, and what kind of impedance it goes into, and so forth. How do you replicate the power line, which would be an interesting concept in and of itself. So we're hoping to get some traction with that, but again, it's a little lower priority until we find out, what is the environment in the first place. 7 is just follow on to what I just said. If there could be a guide to help in, the association between the test laboratory and the customer, where you sit down and write the test plan. Well, we think that we could, once we know the information above, we might have a guide on, we're planning a guide to help in the application when you sit down for that discussion, which of course, as most know, is part of the competency of test laboratories following IEC ISO 17025. Number 8, a lot of protocols. I think the last count I had, I found there were 10 different communication protocols. So when you get these devices, will it work with all of the protocols, or does it have to be identified which specific of the 10 should be used in this particular power line, for example? And if you're going to make a general product, that means you probably should have the capability for your smart meter, for example, to handle all 10. Well, now you're talking about some financial impact, and of course the testing side is as well, because you would have to generate those communication channels, putting information on it, and how do you do that? Do you have a signal generator that has very special arbitrary waveform generators, and the list goes on? I think you get the idea. Number 9 is now showing up. If you, for example, if you have an apartment building with, let's say, 200 apartments, every one of them will have a smart meter, and the smart meters will be placed on obviously an outside wall and usually clustered. So now we have 200 devices that have RF being emitted, and we have 200 devices that have a certain immunity level. And what is that? Because it's kind of like a very poor phased array antenna. The common answer is, well, these meters have to meet FCC Part 15, therefore the emissions are controlled, and that's true, but it's controlled at a 3-meter or a 10-meter separation. Well, we're talking about these things being less than a half a meter separated, and those are never under the control of a typical Part 15 test. So, as you can imagine, in the near field, they will be maybe quite high in level. So that's a challenge. No one solved it yet, by the way, but we're going to look at it from the aspect of near field interoperability. Number 10 is just any strategy that comes out of what we are doing, both short-term and long-term. That'll be part of our report. So with these 10 that I'm showing here, I'm hoping you can get an idea of the thrusts of the working group and essentially the deliverables, but clearly we cannot do 10 at once. Our committee is between 10 and 15 members. The active members are probably less than half that. One of the things I'm doing now is soliciting more people to join. There is an issue that to get on the listserv, and you have to be a registered member, which means paying an annual fee. There is some ability to have part-time technical input from those that aren't paying the full fee, or maybe at this point not paying any fee. And that conversation constantly is going on in the SGIP to allow that or not to allow that. It's still not been a firm decision as far as I can find. But you got to realize that the SGIP is a standalone organization, like any organization that those that are on the webinar are part of, and you got to stay in business. And without a revenue stream, you aren't going to stay in business very much longer. So just keep that in the back of the mind. It's not just to get money from people. It's actually to have some survivability, if I can use that word, of the SGIP itself. So we're all trying to make that happen because we think that the service of the SGIP to the smart community, smart energy and smart meter community is well worth the investment of time. Okay, I think I've given the setup for what we're going to talk about now. I thought the next thing to sort of focus in what I'm going to be presenting at these conferences to the international community might be of interest to be recorded on this webinar. So let me bring up agenda item 2. You can read the title. It is the work of our EMII working group, and you can see it's scheduled for the middle of May. And the idea is there are some standards that we have already in existence that apply. You know, for example, there's a lot of standards on power substation, you know, the switching control and so forth. That in fact there have been communications over the power line for decades, such as, for example, switching capacitive loads on a line that extends out quite a ways, and that's all done over the AC line. Most of the things we're talking about in the smart grid area, it does use power line communications, but there is a strong emphasis to go wireless, and I'll talk a little bit about that as we go through these slides. So there's the name of our organization, and if you go on the Smart Grid homepage, the SGIP homepage, which is sgip.org, and you can find us. In fact, This particular link on the PowerPoint is a hyperlink that goes right to that part of the SGIP website. So here's the picture of, it's sort of a cartoon, but what we have on the top is what we have right now from power generation, transmission, distribution, and out to the customer location. And the customer, could be a home, it could be an industry, it could be a lot of things, including those that have renewable energy that sell energy back into the grid. And again, the smart part of the smart grid will allow that transaction to occur. In the bottom flow or figure is what we now say is intelligent, and that is, quote, the smart part of the grid. And it combines, the electrical, the meter monitoring of power usage, as well as the communication, which I've already mentioned. When do you communicate with cheaper rates of energy and so forth? And there's a lot of things in this cartoon which I don't necessarily go into, but it does also cover, on the far right there, electric vehicles. Whether it's onboard charging on the vehicle or at a vehicle charging station, obviously it's got to get power from somewhere. And the idea is, right now, if you had all electric cars, the power grid would never be able to handle that. So in the immediate future, there will be limited charging stations. It's kind of like when we trying to find a diesel fuel for your car. I know in the area where I live, if I had to have diesel, I'd have to go several miles to find a filling station that would have it. In the center of that flow, you see a cellular tower, and everything can be, over a short distances, can be handled with a wireless communication, which would give the information of the status of the power and so forth. But again, this is sort of an idea that I use to show people that we moved from the top flow and added the bottom part of it. It's an overlay of the top flow. The charter I've already mentioned, so I don't propose to read it. The red is what I highlighted when I talked about the document earlier on. So for these people that come to these tutorials, I usually write down the information and focus with red font what I want to highlight. And for example, the working group effort at the bottom there generally does not encompass a review of general electromagnetics and power-related issues such as power quality. And that's always a question answer. Why don't you handle the harmonics of the power frequency? We are not into that. We are above 9 kilohertz, if you will. So the approach, again, some of this is repetitious to actually what I showed, but I thought it would be useful to show what I will highlight. The second item there is there are priority action plans in the working groups, and priority action plans are, as you might imagine, are focused single unit, single activity. For the EMI working group, we decided we will look at 10 such almost considered PAPs, and from the general purpose of the community, and it's not that important as long as we get, we have output. If you look at the, we put out what we call a white paper of why EMC should be considered on the grid, and right there there's a title. By the way, it's a public document. If you clicked on that URL, it would take you right to the document. And what's there is the table of contents. So we give an introduction, what's EMC in the grid, recommendation for testing, we have a strong interest in knowing what the situation is for immunity as well as emissions, and you don't know that until you perform a test. And of course, from the utility perspective, they're saying, wait a minute, you got to have all these tests. That's going to cost a lot of money, because probably will be close to 1 billion, with a B as in boy, smart meters installed worldwide. And if you have to add, I don't know, pick a number, a dollar immunity patch, if you will, that would just blow the profit margin. So, you know, this is just business as usual. Then we recommend action, carry on action. I showed you the charter. By the way, this was published, you can see there, in 2012, so we've been going at this now for going on 4 years. We have some interesting appendices. We review the standards that we think is appropriate. That's in A. In B, we touch upon the high energy pulse and the intentional EMI, geomagnetic storms, which is not generally found in a suite of immunity tests that are done by EMC test laboratories. There's some advanced metering infrastructure that's going on, and we at least acknowledge that, but again, 4 years has gone by, and that probably would have to be updated. The other thing is that there is a separate organization working group in the SGIP. It's called Home to Grid, H2G, and they look at the interface at the customer location and how that interacts with what's in the home. And you know, for example, do you have smart systems on every appliance, or do you have it at the mains entrance to the house, and to take care of all appliances that are in on a global basis? But as you might imagine, most appliance manufacturers are starting to build in the smart part of their operation. So each one will stand alone in the smart grid activity. So this is a very useful document to put our best foot forward from an EMC perspective. I've already mentioned the Interoperability Process Reference Manual, and I just sort of conclude that it's been put into a NEMA standard. We expect it to be published, by the way, within the next 2 months, and it could be then ordered from ACIL online or from NEMA for that matter. It's not that long a document. It's only got like 7 or 8 clauses, but it's really very well done as far as explaining what a utility might want to do to introduce smart grid activity into the scheme. A lot of chapter topics. I'm not sure I necessarily want to go through it, but just highlight it. The one that I'll talk about more later in the agenda is the extent and severity of the electromagnetic environment, because that's where the action is right now in my committee, to try to get people to help to input it. And anyone that's listening or watching the webinar, that is an open invitation, and I'll talk about that later. So these particular slides just simply go over the topics that were in the original charter that I already talked about. So I'm going to continue on. You'll see these questions raised in a document that's coming up later in the webinar that will address what we need from the extent and severity. So I'm not going to go into the questions because you'll see them again. There's one on the extent of the failure problems, and one is on the severity of levels that are there. To sort of wrap our arms around what's happening in the international world, there is an IEC 61850-3, actually Part 3, that defines, you can read by yourself, defines the general requirements as they are in a power substation. And clearly that is a very difficult RF environment as well, as even from the perspective of safety. So 61850 this has been published for a while now, took the bull by the horn, and it worked on the substation end, which a lot of people, when we talk about EMC, say, well, we should only worry about substation. And of course, my answer to that is you worry about everything along the connection between the power generation and the customer that might have electronics that have to interoperate. And that means they have to interoperate in the environment. So there's a general requirement for the industrial environment is not sufficient for substations. And the difference I don't show it here is well, I guess I do show it later on, is test levels for immunity. We're not used to some of these test levels for common consumer devices. Some of the requirements, you can see there's some that are a little different than what we are used to. The first one is pretty common for lightning and switching surges, surge protection. Discharges and strokes and gaseous isolation media. That's something that we don't usually do, but it does produce transients. And then there's gas insulated switchgear. Again, this is a different, in other words, the product performance degradation is going to be different than what we normally would be talking about for a common consumer device. So there's the suite, pretty much like what we do, but again, I've already mentioned the test levels will be different. And they get into 4-16 and 4-18, which generally is not common in the suite of immunity tests. There is an IEEE version of sort of rounding out. You can see environmental testing requirements for communication networking. Now we're into the communication add-on to the power utilization portion of a smart meter, for example. And you see it addresses equipment enclosures, temperature, electrical, and a host of others. And if you start looking at a table between the immunity requirements of what was in 61850 and what's in 1613.1, you'll see the red ones there was not in 61850-3, and it was added to 16 IEEE standard. And by adding it, you can see we are now rounding off the suite of tests that I just pointed to. So the thing to note here, if you just use the original version of 61850 Part 3, you would not have a conducted test. You would have the radiated test. You would not have a magnetic field test, and you can look at the table yourself. So that needed to be fixed. And when 1613 decided to fix it, they went a little bit further in defining Zone A and Zone B. Zone A is inside the substation, and there's an argument, what does that mean? The general argument is if the substations are usually fenced off for safety, security, etc. So inside would be inside the fence area, which is primarily the control hut and the actual installation. And Zone B would be outside the fence, which is the distribution part, which goes to consumers eventually at downstream. And then you can see the tests for on the substation is twice for the surge and the fast transients, twice the test level that it would be if you are away from the power substation. And you can see inside the substation there's a 20 volt per meter, and outside they just reduced it a little bit to 15. And I don't propose to go through all of this, but you can just see it's almost a doubling of the test level when you get inside a power substation. Continuing on, I don't want to go into too much detail here. There is another standard 61006-5 on environment, and again, there are we don't have time to go through every level there, but the point being is it's still very similar to once you're inside the substation, inside the fence. For example, on the 60 hertz magnetic test, you go from 30 amps per meter to 100 amp per meter test, and it's a triple. And so that is a significant change, and that means you have to have instrumentation that will be able to handle these levels to perform the test. The last thing I wanted to show is acceptance criteria. Some people call it performance degradation criteria, but this is now internationally adopted. It's on the IEC as well as the IEEE. So let's just kind of read through it. And it's very similar to what we kind of are used to in regular consumer UEVD testing. First one is you can't have any damage. Okay, it's damage. It's not, it won't work until you remove the test signal. You can't have any loss or corruption of stored memory or data. So the word no is there twice. Now on the C, the device resets do not occur. In other words, and manual resetting is not required. So you don't want to get into a situation with the product where there has to be a reset. And so that is what's looked for during these tests. And then, of course, changes in states is kind of an obvious one, but it includes, mechanical, status, alarms, etc. And the other one is no erroneous or permanent change of state. Erroneous is the real key word here, because it could be a subtle change of state that is not a state that is ever occurs, but it shows up during the test because the product has responded to that. And so you're in never land, and of course that's something you don't want to do. And then the supervisor control and data acquisition part shall not change by more than 2% of full-scale values. After the test, accuracy must revert to the manufacturer's claim accuracy. So this is when the signal is removed, you can go back to where you started, but if the signal is applied, you can only allow a 2% of full-scale value reduction, which is pretty tight. 2% is not a big number. So the conclusions, I gave information on EMII and so forth. So I think at this point, I'm going to drop this and move on to the next agenda item. Be interesting to see by the response I get, the reaction I get to what I'm presenting. And that might be the subject of another webinar later on in the year. Let's go to now back to the SGIP itself. Let me make this full size. This is the organization of the membership. There are working groups. I've already mentioned the priority action plans, and then there's, of course, usual standing committees of the entire organization. That's grid architecture, cybersecurity, testing certification, and so forth. And there's, of course, an executive board. But on the left is where the EMII working group appears as a working group. So we have home, building, and industry to grid issues. I mentioned already the home to grid. There's business and policy, transmission industry. You can kind of read on down. But the second from the bottom is where we are for our committee, the Electromagnetic Interoperability Issues Working Group. And so someone asked me, where do you fit in all this? Well, there's the flow right there. And all of the working groups report to a technical committee of the SGIP, and it's not shown on this particular visual. They meet every other week for 2 hours, the webinar, and I'm, of course, on that every other week, and I essentially give updates as to the progress of our activity in the EMII working group. So let me close that down. Timetable. Well, let's go to members first. I'm sorry. Number 4. This is kind of interesting to look at who's who in the zoo, if I can use that word. Let me make this bigger. First of all, there's the names of the people that have signed up, and yes means that they paid their dues for 2016. No says they have not, and some of them are being worked on to see can they get money to reapply. So from an ACIL perspective, we have 2 people, and Jerry Ramey is known to us in the C63 world. Then I'm just going to look at, and you can look at the names yourself, but you know, ComEd is a member. We have a consumer electronics person. We have Duke Energy, Ericsson, FERC, which is the U.S. government, Federal Energy Regulatory Commission. We have a couple from the Standards Association, the IEEE, a couple from Itron, which is a very much major into power activity. Meditech is a consulting firm for EMC. NEMA. We have at least 2 of the 3 shown there from NIST, and they are out of the Boulder organization. Galen Kepke, who was the previous chair, has retired, and so he will be removed from this list because he's not active anymore. And then Amanda Stallings gives us the Utility Commission perspective. She's the secretary of the committee, by the way. And Leonard Tillman is, of course, Southern Company and so forth. So that's the players that I have right now. And if you know them, you might want to touch base. And if you don't know them and you want to be added to this list, just a email to me will at least start the discussion, and we'll talk about fees later. But I thought it'd be useful just to show you the broad extent of the members of the working group. They're not just all EMC people. In fact, there's very few there, just EMC people. I'm going to move to agenda item 5 here. Yeah, I'm going to try to make this bigger. Well, first of all, before I make it bigger, every one of us had to supply a priority list and the estimated number of hours it would take to do the list, and of course the topics themselves and the deliverables. And then the last 2 columns, which I'm going to make larger, is an estimated start date and a completion date for calendar 2016. And as you might imagine, this is not a strict requirement, but it gives the technical committee of the SGIP something to know of what to expect from the various working groups. So I put them in, and they are the thing in the column E, echo, is the 10 items from the charter of the EMI working group, which I started this webinar with. And you can see the first one there is the evaluate the electromagnetic phenomena issues, and I've already talked about that as being our main starting point, and I'm going to show a document of where we are in the draft. Said we'd start in January and end it in March. I think that will be delayed. It's probably going to be more like June time frame. But I'll update these as the year progresses. And some of the items which I mentioned, we don't know, and they're low priority. So I didn't even give them a ranking beyond 5. And I just said, year end might be the best time to see if we are through with it by that time. So if I expand this up, in fact, I probably should have done it earlier. By the way, there's a column for do we need money? And of course, the SGIP doesn't have money, so that was kind of an interesting futility. So everybody put 0 there. This is all volunteer work with some corporate backing, of course, especially for those people that are into smart grid, and it's part of their job responsibility to work on the EMI working group as well as the SGIP. So, I mean, I can tell you right now, I've already said that March is too optimistic. I put this together 2 months ago. So I'm going to be updating column G, George, there to be more realistic. But the idea was to go on to the next, the next one that was considered important was the test plan and test setups portion. And it's supposed to start the 1st of this month. I think that'll be put back a month or 2 as well. And you know, the EMI working group, and it's not a 1-year working group. It is a continuum, and those that don't get handled in the first year will be handled subsequently in pursuing next year's. So, you know, I just want to make that point that these aren't time definite working group. Now, having said that, every 6 months we are evaluated as to progress from the technical committee of the SGIP, and my committee evaluation is going to be the 1st of July of this year. So we better darn well have full progress on item number 1 there on the EM phenomena issues, which is charter number 2. Number 2 on our charter document. So I think there's probably enough there. Again, the idea of showing this is a typical Excel spreadsheet that's used in SGIP, and the columns are what is tracked, T-R-A-C-K-E-D. So let me close that down and finish up the rest of it with the review of the starting draft document. And again, I don't want to read through it you know, line by line, but we put out a request for people to come up with their priority of the 10 items, those in the working group. And without exception, very interesting, the charter item number 2, which is shown there in italics, was what they thought should be done first. And I'll just read it. Evaluate the EM phenomena issues according to their potential impact on smart grid reliability. The priority set should consider the extent and severity of possible failures and the availability requirements for relevant communication interfaces. And the NIST document, you know, it's the NIST internal technical report, 7628, has the list of the interface, the communication interfaces, which would be used to set up a communication channel testing a device for interoperability. So that's our focus right now, and we're working on. In fact, I put together this first draft just to get us, you know, some background in the introduction, which then I talk a little bit about the phenomena that we are looking at, and I pulled the table that I showed you, and that I will be showing in the tutorial I'm giving in the Asian Pacific EMC conference in May. Just to, as a starter, to show on the second column, for example, some of the typical tests that we're talking about. So I thought that was important, and of course the list goes on. I combined a couple of tables. You've already seen me talk about this when I talked to the PowerPoint presentation. Then I talk a little bit about the smart grid environment. Again, looking at it from the full complexity of going from the power generation to the customer through transformers, through distribution systems, through transmission systems, and which are different voltages that are coming out of the power substation. In fact, the last sentence is kind of funny. Not funny. Someone said, well, did you take into account that a tree might fall on a power line and discharge it and essentially short it to ground? Well, what kind of test do you use to perform that? Is that a short circuit test on a power line? And you want to be around when a couple thousand amperes flow when you short circuit it? We don't have a immunity test for tree falling. I thought that was kind of an interesting remark, and I put it in here because it typically happens, especially during storms. That would be a nice standard to write, by the way. I think that would whet my appetite even. Then I show what I've already shown on the figure. And the challenges are, and this is where we get into the questions. Priorities should be set to consider the extent and severity of the failures. And I'm going to just show you the questions that are coming up. For the extent of the failures, here's the questions. Do we have credible reports on problems that occur in the field? Are there hotspots where most of these problems occur? That's number 2. And number 3 is, do these end up being spread across the entire grid? In other words, trying to see what is the extent of the problem. Is it very isolated, or is it throughout the system? Those questions have to be answered in our report. So that covers the extent, and I'm going to go on then to the other part right away, where are the questions on the severity. We need to employ EM environments documented. This is 61002-5 is a technical report on environments caused by known transmitters at particular separation distances. And it's we have information of what is typically wire, transmitters in and near power substations. So that's very useful. So we'll be drawing heavily on that document. Number 2, gather data on the levels that affect devices. In other words, if I go and ask a smart meter manufacturer, what is your immunity level to fast transition bursts or radiated electric fields? You can imagine the kind of answer you would get. Number 1, what are you talking about? And number 2, for those that maybe have done or their supplier have done tests, well, it's in a test report. We should be able to get that. Or you might be pleasantly surprised, and the report's in front of the person you're asking the question of, and here's the information. And that's the kind of gathering we're talking about in item 2. Item 3 is the high power pulsing, including geomagnetic storms, for example. But the difference between high power and high energy, power energy is a function of time. And high power, in other words, the actual level of the voltage, for example, over a long period of time has a lot of energy, but that same high voltage over a nanosecond has very little energy, but it certainly has high power, because when you would use I squared R, you would end up with a high number, or E squared over R. And so the difference between power and energy is what I just said. And then the last one is, I've already mentioned, what do we do with multiple exposures? This is, remember, the smart meter sitting on the side of the house. So I'm going to close this and then end with the tasks that I've been asking the working group members to do. And so we broke it up into, and I don't think I can get it all on one page. These are the questions I just went over. We broke it up into 2 task groups, one on the extent, headed by Jerry Ramey of ARC Technical Resources, And one on severity, temporarily I'm heading that one up. I have someone in mind that might take over herding that information. The bottom line is that for those that are on the webinar or view it later on, there are needs to answer these questions, and if anyone knows of a colleague that can present information to us, and as I mentioned earlier on, if we're talking about incidences of problems, we can only put it in our document if it's recorded and publicly available. As you might imagine, there are power companies that don't want people to know that they're having a problem, and there are manufacturers of devices that don't want people to know that it's fairly susceptible to RF, for example. So we run that tight line by, and usually what happens, and I'll tell you right now, if it's released as a news item on the local evening news, that is something that's obviously public. And we've had incidences of actually nuclear control shutdowns due to a device emitting a signal that is a typical consumer transceiver. So those are obvious ones that are in our report or will be in our report. But the point being is we're not looking for ghosts, or we're not looking for you didn't do your job. We're looking for incidences where we think as EMC people can be solved at a reasonable cost and a reasonable test. And so that's the challenge that I put forward to the entire working group. So that group of people I showed on the list, they would have received by this morning, and which is the 16th of March, a request for them to help in answering these questions. And I broke up the group into extent and severity almost arbitrarily, but thinking ahead. The utility people, I was interested in, the extent of what they have come into. For the severity, that was a broader group, and those usually are incidences that get almost front page coverage in the local paper. So with that, I think I've covered all I wanted to on the webinar. I would just sort of concluding remarks here. We do need volunteers, and it doesn't have to be those that are watching or on the webinar. It could be colleagues that, and we're not talking about a lot of time, and everything is done electronically by webinars. We have the ability to have webinars set up for subgroups to communicate live and see a document in front of them. So we feel that there's no travel and therefore no cost in that and no time wasted by being on a plane. And that's the way I work, and fortunately this is the way that ACIL wanted these webinars presented. This work on smart grid is going to take years. In fact, probably it'll take a better part of a decade. So it's not necessarily I'm asking for a career, but if there's something that we can do to answer some of the questions that's available, I would appreciate it. My email address is d.heirman, H-E-I-R-M-A-N, @IEEE.org. I'd be more than happy to answer any questions directly by email. So with that, I've concluded the webinar, the ACIL webinar on the activities of our EMII working group, and hopefully I've given enough insight of what we do and how we do it and what the challenges are ahead. And I thank you for listening and paying attention to, and perhaps getting involved with us at some point in time. So with that, I close the webinar.